Hello everyone, I hope you have a good day. And now we will talk about observability for serverless. But before I will talk about how to do it with serverless in AWS, I need to, let's say, introduce my approach to observability, what observability really is, and what we still kind of miss in observability. And before we will go there, let me ask you a very small question, but important one. How good is your monitoring? Are you happy with it? Do you know how to improve it? Do you know what you miss there? Are you sure that your monitoring is aligned with your business needs? Okay? That's the questions we need to answer. Right, so my name is Piwosz and I've been working for Spacelift as developer advocate for a couple of days today. So this is quite new for me. And also I am DevOps Institute ambassador, AWS community builder, and CD Foundation ambassador. So now you'll know why I will talk about AWS, right? Okay, so what is the problem today? We have less visibility, right? How I understand it, how we should understand it. So first of all, when we had bare metal, the rack and some servers in this rack, in the data center, we could observe everything, right? Starting from air conditioning through the power flow to the end behavior of the application by every single user, right? Then we went to virtual machines. And as long as we are not responsible for this virtualization platform, we do not have the visibility there. So we can see everything what is above, not below, right? Then we have containers. And we can see even less. For example, if you think about ECS, especially Fargate ECS, right? Or just ECS. We have less and less places where we can observe and understand what our system is doing. Especially if we talk about Fargate, we don't know almost nothing, right? And finally, we have serverless. And in serverless, we deliver the code, we deliver the information, what is the endpoint of the API and what it should do, and that's all. We don't see anything else, right? And why is that? Because we have less interactions with the systems through the whole scope of the system. We have less accessibility to the system. We have more and more tools. We start to think that central logging is passé. And this is the problem which came with Agile, in my opinion, especially when we say that all teams should be self-organizing and they know what they do and that's it, right? Yes, but on the end of the day, it's the company who sell the product, not the team. And if you have multiple teams working together, you see the problem? If you have monitoring only of your own component without caring about anything else, because it's not your responsibility, it's other team responsibility, what can go wrong, right? I saw examples of this. And believe me, today I can laugh from it, but it wasn't funny that day, okay? And finally, we have decoupling. And this decoupling of the system, microservices, serverless, etc., is bringing more and more complexity, at least in the communications pattern, right? And here we also need to think not only about the communication between the components themselves, but also between the teams. So Conway's law. I don't want to go deeper into this topic, but this is really interesting one. So what does less visibility means? Well, exactly this, right? So we have different computing models, and on this picture you can see that the greens are the elements which we control, and the reds what we do not control in any of these computing models. So we have a couple of approaches here. We have on-premise, simple, we control everything. We have infrastructure as a service, platform as a service, software as a service on the end, right, where the serverless lies. And here, as you can see, in this approach with software as a service, we do not control anything except code. And this brings this complexity, right? However it sounds. Okay, so first of all, we need to have like a cultural shift. Why this is important? Because we cannot catch logs as we used to do. So we need to create new, sometimes even more complex, more responsive ways to do that. And first element which I need to present before we go to the observability is something what is called structured logs. Okay, and what is structured logging? This is the definition from Samologic, and the structured logging is the practice of implementing a consistent predetermined message format for application, blah 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 blah, right? So generally what it means that our message from all the systems should be as much informative as possible, as much organized as possible, and following the standard as much as possible. This message also has the standard, right? So how it looks in the example, we will see it, but please remember one thing, that structured message is not the structured log. Structured log is a little bit more. So we have structured message, and around this we have structured information why we have this message, what happened in the system, right? What is system is doing at this point. So standard log line example, especially from sysadmins, this is very, very, very common and very, thing which is very familiar, right? When we want to structurize the message, we can do something like that. And this is the hint how to become senior. You just put your message into the JSON. And that's it. Sounds silly, but believe me, it's already a huge upgrade. Why? Because your systems which are working with your logs doesn't need to process the message as heavily. Okay? Because with JSON, it is very simple. You have fields, you have values of those fields, and that's it. You don't need to look, you don't need to create the patterns to search through the logs, etc., etc., etc. It makes things easier. Then we have structurized log example. It's not fully structurized yet. I mean, it's not the structure log itself, but the line is pretty nice, right? So we have information about the message, and also, for example, who, from where, etc., etc., etc. It's a lot better, right? But still, this is a good start, but this is not the structure log yet, okay? And to have full structure log, we need to go into observability. But please remember one thing. Observability is not Grafana on Kubernetes. If you have Grafana on Kubernetes, you don't have observability, you have Grafana on Kubernetes, period. Yes, this is the tool, very nice tool, which we can use in order to, let's say, complete the whole approach to observability, but this is only the tool, nothing more, okay? So what are the elements of the observability? 3 of them: logs, traces, and metrics. So what we can talk about, what we can tell about logs. So this is very common scenario. We write everything to logs, right? But we write errors only because we must save money. How many of you are or was in this situation? Okay? So the problem is that if we write errors only, we can forget about everything, honestly speaking. And I know that it sounds tough, but this is really the truth in terms of observability, right? So what are the logs here? First of all, they need to be structurized. We mentioned that. They need to be consistent throughout the whole system. They need to cover all information needed. They need to be constructed for automated systems, because on the end, we want all of these elements, all of these components here to be managed and, let's say, processed by automation, not us. We want to sleep at night, right? They need to be collected consistently. What about the performance and the metrics? Generally. So how many of you, again, were in the situation when you were asked about the performance metrics and you said that's great because in fact you don't know really, right? Because, for example, you have only collected errors from nginx, right? So what about the metrics then? They need to be structurized, they need to be consistent, they need to have context, they need to have full information, and as you already probably start to think, hey, this is almost the same slide like the one before. Yes, you're right. It is. I'm lead, right? They should be constructed again for automated systems and collected consistently. Okay? And very important element, they need to be relevant for the business. Because on the end of the day, the business is the one who is paying for your systems. Right? Okay. Of course, we can collect them directly as a metrics, or we can, let's say, convert logs to metrics as well. What about traces? Traces are the elements which we, let's say, use not that often, right? So logs, it is quite obvious. Metrics, we collect them. But what about traces? So if your business will come to you and will say, hey, I have this John Doe who is claiming that the request took too long for him and he is annoying and he is paying a lot of money to us, please tell me if he is right with this. What you will do in order to prove or disprove that everything is okay with your system, with your complicated microservices system for this specific request. Probably you have the problem. So what about traces then? Of course, they need to be consistent. They need to be collected consistently throughout the whole system. They allow to track the request through the whole system, really, right? And we can use them as a performance measures. And we have a zooming option. If we are very close to the system, we can observe one request for one specific user. If we zoom out, we can see the whole system in general, right? And now, what about the context? I mentioned this context. And I believe for the observability, for monitoring, for all of these aspects here, context is a clue, right? It's the heart of everything. So tell me, please, what it is. I give you like 5 seconds to think about this. 5, 4, 3, 2, 1, 0. That was very quick seconds. So some of you will think probably stone, or I don't know, maybe something else, right? But how many of you thought that can be a planet, fragment of the planet? So without context, you just guessed, correctly or not, but it was only the guess. And without context, you lose something, right? So what is the context in the observability? So first of all, logs allows us to understand the surroundings. Then traces allows us to understand the path, the journey. And finally, metrics allows us to understand the scale. Okay? So please don't tell that there's something in the logs. because if there is something in the logs, you should do something. And the important is what those somethings are. Okay? So please avoid this headache. Just know what you have there. Around this, I built something what I called very creatively meal. And honestly speaking, I built this before the observability became the buzzword. So meal contains 4 elements, not 3 like observability: logs, events, metrics, and also actions. And generally what it means that in this framework, mine framework, we don't only collect stuff, but we also want to automatically act on it, right? It's quite, well, it is in the observability somehow, but I was the first. So generally what we have metrics, events, and logs, right? And we collect them together, and based on it, we take action. And this action can be automated. So enough for the theory. Now we have a little bit more than 10 minutes, so let's go through the tech stack which I want to show you. So first of all, we have Lambda, right? AWS Lambda. This is the serverless compute engine from AWS. And we have one issue here, which we can very nicely observe with the proper approach to observability, which is not possible without it. So if we are experienced enough, we can see this issue, but we are not able really to measure it. And what I mean by that is cold start, right? So we can measure cold start with Lambda Insights. And here we will see how many invocations suffer from this cold start. And using X-ray, excuse me, we can see what is the impact of this cold start on each invocation. So generally, cold start looks like this. This is the time when the AWS needs to prepare everything for us to execute our runtime. And also, there is another type of cold start, but this is not the talk about cold start. So we can have shortened cold start, and when the Lambda is, how we call it, warm, there is no cold start at all. We just go to the execution. In order to deploy the environment, I used AWS serverless application model, right? This kind of framework, which is in fact CloudFormation, right? So infrastructure as code. This is the extension to CloudFormation. And with that, I created something what I called standard example with standard logging from AWS. And this is the code of this SAM, right? Template. So what we have here a couple of elements. So first of all, I define the resource, which is the serverless function, Lambda function. I say where is the code here, right? From where it needs to be deployed. What is the handler to my function? So what will be executed first when the request comes? What is the runtime? Memory size, timeout, and the event here. It means that I assign somehow the API to my function, and in order to reach my function, I need to go to the simple path / with method get. Simple like that. So what we have after that, and this is 20 lines, right? So we have Lambda function, which is created in AWS, very nice. We have, that was the API gateway. It was created for us also with the proper endpoint / like I said. Then we have our Lambda functions. And when we execute this, and I want to go into the metrics, measurements, logs, etc., I will see something like that. Nice. I see that my API gateway was triggered. Good. All right, what more? I see that my Lambda function was triggered, and I have some information here. So how many invocations? What is the duration? But why here is like 2.2, and here is a little bit more than 1.5. Why? It's not saying anything about that, right? So maybe logs. And those three elements here opened shows us the all information which we have by default from Lambda execution. Very informative. All right. So we can agree, I believe, that it's useless, or almost very close to be useless, right? Next to be useless. So how we can improve this? So first of all, we will enable X-ray for the our Lambda. So we need to go into configurations, monitoring and operation tools, click edit, and just enable X-ray tracing, right? And by one click, we can become regular engineer. Then we can do the same thing for API, right? So we go into our API stage, logs tracing, and enable X-ray tracing. 2 clicks, and we are regular engineer. And we have something like that. So we can see here the request path, response distributions, etc., etc. Nice, very nice. And also we have information like that. So we have the traces, we have the information about all our executions. Please don't look on this last one here, because as you can see, there is no get. That means that this execution was done without API. We are interested in all of those which were run through API. So we have the fastest execution around 16 milliseconds and the slowest 28 milliseconds. Why? The same execution. I mean, the same function. Let's try to find out. So we go to the traces. Now we are in the trace which is the longest, and we see kind of gap here. And when we go into the shortest one, we see this gap here as well. It's a little bit shorter, but again, it doesn't say anything, right? We have invocation somewhere here. Is this cold start or not? What happened here? I know, because I work with Lambda for, I don't know, 8 years or something. I know, right? But not everyone knows. So what we can do, we can enable Lambda Insights. So again, we go into the same configuration for the Lambda, we enable enhanced monitoring, and after some time, we will receive another screen, another, let's say, board, where we can see also the information, like a more detailed information, what was the memory use, the CPU time used, the network IOs, but also we have the duration and init duration. And here we can see that the init duration, we can understand it as a cold start, okay? So this invocation suffered from the cold start, those not. We can also enable tracing and logging in the API, right? So we go again to the same position, the same config screen in the API, and we enable all of them, enable CloudWatch logs, etc., 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 right? So those. And additionally, what I suggest is to add the log format for your logs from API. It's called custom. We enable it by clicking this tick here, and we put this. And now the hint how to become senior engineer, this was filled by clicking the JSON button here. Nice one, right? So I added here only one thing, trace ID, just to have the trace ID throughout the whole system. Okay, and of course we remember about keeping this tracing enabled. And after that we have information from API. So good progress, right? We can use something what is called contributor insights to have different boards, different view, different understandings of what's going on in our system. But all of this was only about the exteriors. What about things which happening inside the function? So here we have AWS Lambda powertools. So it's open source project from AWS, which is very close to the OpenTelemetry. And we have multiple ways of implementation. It is ready for Python, TypeScript, Java, and .NET. And we can build the observabilities almost out from the box, right? And the best use of it is using AWS Lambda. Finally, with that, we can start implementing the code, right? So what we will have is that after the implementation, we have full information what's going on in our functionality, right? Even going into specific sub-functions, information about the initialization time, etc., etc., etc. It's much, much more rich than it was before. We can have additional metrics, like a custom metrics. So those metrics are created by powertools, of course, by instrumenting it by me. So I can, for example, a simple example here, I can count how many times the sub-functions were called, right? For the logs, this is the information which we have. So much, much, much richer. We have all the surroundings. We have very, very, let's say, organized output, which is always the same, right? And for the SAM model, I don't know it is, I know that is quite small, but the change for the infrastructure as code, which I've done, is by adding 67 lines, right? Because it can be less, but I have this format described here as well, right? So I didn't do that in one line, but in multiple lines. So if you want to, let's say, implement it by yourself with Python, you can try with this article. And what we can do with that, a lot of things, really, because we have CloudWatch, we have a possibility to analyze this through Athena. We can go into QuickSight through OpenSearch and Kinesis. We can put it into TimeStream and publish data through Grafana, right? Or send it to Prometheus, whatever. We can build alerts and alarms on it and act on it using, for example, lambdas, right? So there is a lot. So for the instrumentation itself, except powertools, what we can use. For, of course, powertools, right? But also Jaeger has the possibility. Prometheus has the possibility to instrument your functions. OpenTelemetry has also the possibility to do that. For visualization, we can use Grafana, we can use Prometheus, we can use many, many other tools, right? For the databases, we should use NoSQL databases. It's, I believe, obvious. Mainly time series, especially for metrics, but for logs, for example, OpenSearch, right? And we have also all-in-one tools like Prometheus, like Jaeger, like Honeycomb.io, very nice tool, which allows you to control the whole process, right? Dynatrace, for example, as well. And Splunk is quite new, but Splunk also allows us to build the observability. And finally, the question for you on the end. Who is monitor your monitoring server? It's a quote from DevOps Borat. If you have questions, I'll be happy to discuss it with you. You can contact me and connect with me through the LinkedIn or on my webpage. And also I strongly recommend, I ask you to subscribe to the podcast which I host with my two friends. We talk there about IT with different aspects of IT. Thank you very much for your time. Enjoy the rest of the day. and I hope this talk was useful for you. Thank you.